Now in this video lecture we will understand some of the structures of electrovalent compounds. First we will take example of compound which we have already done in our previous videos, sodium chloride. And as we already know that sodium chloride has electronic configuration 281 and chlorine has electronic configuration 287. So sodium has one electron in its outermost shell. If we can remove this one electron, it will change into this electronic configuration of sodium metal will change into stable electronic configuration 28, which is the stable electronic configuration of nearest noble gas. Similarly, chlorine since it is a non-metal, it has a tendency to accept electron. Chlorine has 7 electron in its outermost shell, to gain octet 8 electrons पूरा outermost shell में करने के लिए it needs 1 electron. This 1 electron would be transferred from sodium metal. Sodium metal, it's a metal since it has a tendency to lose electrons. Sodium metal will lose electrons which would be gained by chlorine atom. Sodium atom एक electron देगा जो chlorine atom gain कर लेगा to form sodium chloride, compound sodium chloride. Now we will look more into this. This is sodium के electronic configuration है 281. It will lose 1 electron to form sodium ion. Sodium ion has stable electronic configuration of nearest noble gas, which is 28. It has attained stability. Similarly, chlorine has 7 electron in its outermost shell. It will gain 1 electron and it will form chloride ion, thus making 8 electron in its outermost shell to achieve stability. Right, so we'll quickly draw the atomic structure of this sodium chloride molecule, electrovalent compound. It has first orbit has 2 electron, second has 8, 1, 2, 3, 4, 5, 6, 7, 8, and the outermost valence shell has 2 electrons. Similarly, chlorine, we will draw the structure of chlorine. Chlorine has seven electron in its valence shell. 3, 4, 5, 6, 7, 8. So sodium, this is a sodium metal. It will transfer 1 electron to chlorine atom, right? Since sodium atom is losing an electron, it will acquire +1 charge, sodium ion. It will become a cation. Similarly, chlorine, after gaining 1 electron, will become chloride anion. And hence, since sodium and chlorine developed opposite charges, sodium plus chlorine, sodium ion plus chloride ion, these ions has high electrostatic force of attraction between them, hence it will become sodium chloride. Sodium chloride is a solid compound that has high melting point, high boiling point, and is a good conductor of electricity in solution. Right? It is a solid. Why it is a solid? Because of high force of attraction between sodium and chloride ions. Right? And why it is a good conductor of electricity in solution? Because when you dissolve this sodium chloride molecule in water, water has ability to break the electrostatic force of attraction between sodium and chloride ions. Hence, sodium and chloride ions are mobile in solution state, due to which it is a good conductor of electricity. Now coming on to the next example, magnesium chloride. And one more thing I want to tell you, that sometimes in exam you may get that draw the electron dot structure of sodium chloride. So electron dot symbol, what is an electron dot symbol? Electron dot symbol is represents how do you represent electron dot symbol? Like hydrogen. Electron dot symbol for hydrogen would be this. Electron dot symbol represented by symbol of element surrounded by the valence electron. Hydrogen, it has one valence electron, so one valence electron. So one electron surrounded by one electron. Similarly, oxygen, electron dot symbol for oxygen is symbol and the number of valence electrons surrounding the oxygen atom. 6 valence electrons, since oxygen has 6 valence electron, so इसके हम चारों तरफ 6 इलेक्ट्रॉन्स ऐसे ड्रॉ कर देंगे ऑक्सीजन एटम के चारों तरफ. अब अगर हमें इसका इलेक्ट्रॉन डॉट स्ट्रक्चर बनाना है इस पूरे का, हम क्या करेंगे, सिर्फ हम इसके आउटर मोस्ट इलेक्ट्रॉन्स को रिप्रेजेंट करेंगे उस डायग्राम में. जैसे सोडियम का एक इलेक्ट्रॉन, क्लोरीन, राइट, इसका एक इलेक्ट्रॉन ऐसे जाएगा, ट्रांसफर किया, so it will form this. Now it has 8 electron, this is the electron dot formula of sodium chloride. Now coming on to calcium chloride. Calcium chloride is it's magnesium chloride. Magnesium atomic number 12, electronic configuration would be 2, 8, 2. It has 2 electrons in the outermost shell. Similarly, chlorine has 7 electrons in its outermost shell. So how does the solution of how does this magnesium chloride forms? Two electron, 1, 2, 3, 4, 5, 6, 7, 8. It has 2 electrons, right? Since it has 2 electrons, it is a metal, magnesium. Now coming on to chlorine, I'll just instead of making this, I'll just make the I'll just show the outermost electrons only. 4, 5, 6, 7, right? The other chlorine 1, 2, 3, 4, 5, 6, 7. Now magnesium will transfer 1 electron to this chlorine, right? After losing 1 electron, it still has 1 electron which it can lose easily. Other electron it will give to the other chlorine atom, right? So it forms, it loses 2 electrons, so it forms plus 2. Now we have 2 chlorine minus, right? And it forms, this is a cation, this is an ion, force of attraction, forms magnesium chloride molecule, right? So if we just draw the electron dot structure, magnesium, 2 electrons, chlorine, 1, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7. We have 1 electron to this, 1 electron to this. Right? This minus charge, right? These are 2, minus 1, minus 2, minus 2. It will form. This is how magnesium chloride is formed. Magnesium transfers 2 valence electrons to 2 chlorine atoms. Since after losing 1 electron, it still can lose other electron. It's still unstable. Since it has 1 electron, so it is still unstable. The other electron it will give to another chlorine atom. Hence, the formula of the compound is MgCl2. Coming on to the third example, which is calcium oxide. Now, calcium has 2882 atomic number 20, electronic configuration would be 2882. Similarly, oxygen has 6 electrons in its valence shell. So oxygen needs 2 more electrons to gain octet, and calcium can lose 2 of its valence electron easily to the oxygen atom. Right? Oxygen 6. Right? Since it loses 2 electrons plus 2 charge, it gained 2 electrons. These 2 electrons, right? It will develop minus 2 charge. So this is cation, this is anion, high force of attraction between two, it will form calcium oxide. So now one more thing you need to check in this, it's important, little important, since this sodium or magnesium or calcium, we notice that these are losing electrons, right? Similarly, chlorine, oxygen, they are gaining electrons. We might have studied in previous classes that loss of electrons, this loss of electrons, this is oxidation, and chlorine gaining 1 electron, this is reduction. So since oxidation and reduction taking place simultaneously in this reaction, because sodium is getting oxidized, chlorine is getting reduced, so this is an example of a redox reaction where oxidation and reduction takes place together. We call it a redox reaction, right? And this sodium is a reducing agent. We call the metals, since metals have tendency to lose electrons, right? They are called as oxidizing agent. Similarly, non-metals, chlorine has tendency to gain electrons. These are known as oxidizing agents, right? These are oxidizing agents, and these are reducing agents. Reducing agents, since they can lose electrons and can reduce other non-metals, these are known as reducing agents, and these can gain electrons. Which means they can take electrons from non-metals. So these are oxidizing those non-metals. These are oxidizing agents and these are reducing agents. And I hope this cleared your concept of formation of electrovalent compounds, and we have electron dot formula which you may be asked in exam, oxidation and reduction, right? And one thing, there are certain properties of electrovalent compounds that you need to keep in mind. The electrovalent compounds, all electrovalent compounds are solid. Why? Because of high force of attraction between oppositely charged ions. These are solid at room temperature. They have high melting and boiling points. Why? Because of the same reason, high force of attraction, you need to give more energy to electrovalent compounds to overcome that high electrostatic force of attraction to free ions from electrovalent compounds. And electrovalent compounds are good conductor of electricity in solution, that is, they are strong electrolytes. Why? Because water has tendency to free ions of electrovalent compounds in solution. अगर आप सोडियम क्लोराइड के मॉलिक्यूल को या मैग्नीशियम क्लोराइड के मॉलिक्यूल को पानी में डालते हैं तो पानी में सोडियम क्लोराइड अलग हो जाएगा और क्लोराइड आयंस अलग हो जाएंगे, मैग्नीशियम और क्लोराइड आयंस अलग अलग हो जाएंगे. सिमिलरली सोडियम क्लोराइड डालेंगे तो सोडियम और क्लोराइड आयंस अलग अलग हो जाएंगे, बिकॉज वाटर इज अ पोलर solvent and it has tendency to break the electrovalent compound into its constituent ions. इसके constituent ions में water electrovalent compounds को break कर देता है, and if you pass electric current through a solution of electrovalent compound, it will conduct electricity. So electrovalent compounds are strong electrolytes and is a good conductor of electricity in solution. Hope this helps you. And in the next chapter, in the next lectures, we will start with other type of bondings like covalent bondings and dative bondings. And if you have any questions, you can post in the comment section. I will try to get back to it. Thanks.